Good morning. Welcome to the Diesel Technology Forum's webinar, Using Biodiesel, Good in Theory, Good in Practice, Looking Beyond the Policy and Politics. During the presentation, all participants will be in a listen-only mode. As a reminder, this event is being recorded. To ask a question at any time during the event, submit the question via the Q&A box. We encourage you to ask questions at any time during the presentation. Your questions will not be viewable by other attendees and will be addressed during the Q&A at the end of the session. I'd now like to turn the call over to your moderator for today, the Diesel Technology Forum's Executive Director, Alan Schaefer.
Thank you, Kristen, and good morning, everyone. Thank you for being with us today for this webinar regarding biodiesel, as Kristen has mentioned the title. I'm delighted to have the chance to bring together a really expert panel representing a number of important different views about the use of biodiesel. As everyone on the call knows, this is a growing topic of interest. Production of biodiesel in the U.S. in 2008 was around 700 million gallons, and we have a growing interest in further use of renewable fuels like biodiesel within the federal government and legislative process right now to enhance our energy security, provide a low-carbon fuel strategy, and to help address climate change, among other things. And we have seen a tremendous growth of biodiesel production in the last few years, and much attention has been given to the supply side of the biofuels equation. And now as the possibility of a more widespread use of biofuels becomes clearer, we thought it was both timely and important to bring forward a number of different perspectives about the policy and issues regarding the use of biodiesel in diesel applications that are out there today. So we have a very interesting audience. Looking at our registration list, we have a mix of folks representing government at the federal, state, and local level. We have a number of folks that appear to be fleet managers of some kind, both for private and for public fleets. A number of academic organizations, universities, and research institutions are online today. A number of non-governmental organizations representing environmental groups, school bus operators, equipment dealers, and manufacturers representing both light and heavy-duty vehicles, as well as fuel refiners and other suppliers. Today's participants come to us from 4 different countries of registration, including Pakistan, Canada, Germany, and the United States. Without any further delay, let me say just a brief word about the Diesel Technology Forum. This is the 5th in a series of webinars this year and will be our last one for the year. But the forum brings together folks that are interested in diesel-related issues. We have representatives that cover the manufacturing of diesel engines and components, fuel refiners, companies that make emissions control technology, and we conduct events like this to help educate policymakers and users of diesel engines and fuels to better advance understanding about this technology. Today's program is going to feature these 4 panelists, and we're going to begin with Bob McCormick. He is well known in the biodiesel community. He is Principal Engineer of Fuels Performance at the National Renewable Energy Laboratory, and he is speaking with us today from Golden, Colorado. Bob, we're very interested in hearing your remarks.
Well, good morning, Alan. Good morning, everyone, or good evening, depending on where you are. Waiting for my slides to come up here. Well, what I'm going to do is give you a brief overview of biodiesel status in the United States and the status of some of the barriers to expanding markets for biodiesel. There we are. I'm sure probably almost everyone on this call is familiar with what biodiesel is: fatty acid, monoalkyl esters, predominantly methyl esters, with a number of useful properties as a diesel fuel. And in the U.S., one of the enablers for biodiesel markets is the $1 a gallon blender tax credit, currently set to expire at the end of this month. I say likely to be extended with a question mark, because one never knows exactly what the U.S. Congress will do, but I think I and everyone in the industry is very optimistic that this tax credit will be extended into the future. Biodiesel production is in the U.S. is shown on this chart. This is in maybe a little different way than you're used to seeing it. It's in gallons per calendar quarter. So what it shows is that in the last quarter of 2008, there began a decline in production in concert with the dramatic drop in petroleum product prices, making it much more difficult for biodiesel to compete with petroleum-derived diesel fuel prices in the U.S. And then this was also made worse by the U.S. government's non-implementation of the Renewable Fuel Standard Part 2, which likely will be implemented in 2010. So 2008 total production, according to the Energy Information Agency of the U.S. Department of Energy, was about 800 million gallons, and 2009 production is projected to be about 475 million gallons. So I think it's safe to say that 2009 has been a rough year for U.S. biodiesel producers. One of the important things that addresses many of the market barriers for biodiesel has been the development of Astm specifications that ensure the quality of biodiesel. The D6761 specification for B100 has been around for quite some time. This is for B100 to be used in blending petroleum diesel biodiesel blends up to 20%. There have been a number of changes, more than just the two I list here, but a number of changes made over the past, say, 2 to 3 years that were necessary to move biodiesel blend specifications forward at ASTM. I think the more important ones were oxidation stability and the addition of a cold soak filterability requirement. Based on these changes to the B100 requirements, ASTM D975, the conventional diesel fuel spec, now allows up to 5% biodiesel in conventional diesel fuel. The heating oil specification also allows up to 5% biodiesel. And then there is a separate specification for higher level blends. For the D975 and D396 specs, the performance requirements for B0, or 100% petroleum diesel, are essentially identical to those for B5. In the B6 to B20 specification, there's some modification of the requirements and the addition of some new requirements that appear to be necessary if you want to use these somewhat higher biodiesel blends. So I think the two things, as I noted, that seem to be the most important changes are the addition of an oxidation stability requirement. So this is a requirement that the B100 has to meet to ensure that it's adequately stable in storage. And then the stability of the B100 is really the main factor that affects the stability of the biodiesel blends. And then also the cold soak filterability requirement. This limits the presence of minor impurities in biodiesel that have been shown to precipitate out at cold temperatures, but temperatures above the cloud point, and in some cases cause fuel filter plugging in winter conditions. The cold soak filterability requirement was added a little more than a year ago, and by all accounts it's led to a dramatic improvement in the quality of biodiesel, both in terms of a reduction in low temperature operability issues, but there's anecdotal reports that it's led to improvements in a number of other ways as well. Related, I think, to ASTM specs is the position of the engine manufacturers with respect to biodiesel blends. Basically, I'm not going to go so far as to say every engine manufacturer is approving of 5% biodiesel, but very nearly every engine manufacturer approves up to 5% biodiesel. Some approve higher blends, B20, and in a very limited number of cases, there's approval for even B100. There's a detailed list that can be found at the National Biodiesel Board's website. These position statements are updated very frequently by the OEMs, and so it's important to not rely on a year-old statement from a particular OEM. You really need to look and see what the most recent information is. Some of the things that are limiting certain OEMs to B5 include concern about lube oil dilution from the fuel. Fuel always gets in the lube oil, but for engines that slightly older engines, this hasn't been a major issue. For engines that use the engine's in-cylinder fuel injector to inject fuel during the exhaust stroke to regenerate the diesel particle filter, you can get very high levels of lube oil dilution with fuel, whether it be biodiesel or conventional diesel fuel. But concerns about having these higher levels of biodiesel in the lube oil are preventing some OEMs from approving higher blends. Now, the biodiesel industry has a quality program called BQ9000, and essentially this requires the company that wants to be a BQ9000 company to develop basically a manual of procedures that they will follow to ensure that every drop of biodiesel they produce meets D6751. And then in addition to having these procedures in place, they are audited on site to see how they're implementing the procedures and to ensure that they're actually doing it. This has been a very successful program, in my opinion. Over the years, we've gotten to the point where certainly more than half of the biodiesel production in the U.S. comes from BQ9000 companies, and over the past year it's been closer to two-thirds. We have, at NREL, have periodically surveyed the quality of biodiesel in the United States by collecting B100 samples. The last time we did this was in 2007, where we collected samples from biodiesel producers representing 70% of the volume of production. We found that overall 90% of the production volume was meeting the requirements. For there were 15 producers that produced well over half of the biodiesel produced that year, well over 3/4 probably of the biodiesel produced that year. And for those producers, there was 94% of the production volume complied with the spec. We had one sample out of that group that failed for water and sediment, so somehow became contaminated. And then in the medium-sized producers, there was really a much poorer level of compliance, although at least one of the medium producers was a BQ9000 company, and their product was in compliance with the spec. And then the very small-scale producers had a much poorer record of compliance with the spec, although I have to note that we've worked with a couple of small-scale producers that do produce a high-quality product. We currently have a biodiesel blend survey underway this winter, and in the spring we'll be doing a new B100 survey to see how the industry is doing now. I'm going to shift gears a little bit from my last couple of slides and talk about biodiesel's impact on air pollutant emissions and emission control equipment. There seems to be a pretty broad consensus that for engines not equipped with a diesel particle filter, biodiesel will reduce emissions of particulate matter, CO, and total hydrocarbon. For NOx emissions, there's been less consensus on what the effect of biodiesel is. The chart on the right, or on the left, shows data for B20 that was compiled by the EPA in their 2002 report on biodiesel emissions. The average for B20 is about a 2% increase in NOx. We have undertaken a reanalysis of these data and also brought in a lot of newer data and thrown out data that we don't think is relevant, in particular data for two-stroke bus engines, which currently make up less than 0.5% of the in-use fleet in the United States. And when you do that, you get the chart on the right, which shows a much smaller average NOx increase of about 0.2%. And just a simple statistical analysis would indicate that the engine-to-engine variation in NOx emissions is so high that it's not really possible to say what the impact of B20 is on NOx. It's small. It might go up a little bit. It might go down a little bit. But the data set doesn't really allow you to distinguish the change from an average of 0. And then the last thing I wanted to bring up was really ongoing research on how biodiesel affects advanced emission control technologies such as diesel particle filters or urea SCR catalyst systems. All diesel engines on road in the U.S. today are required to have that are sold today are required to have a diesel particle filter, and beginning next year we'll start to see the introduction of NOx reduction catalysts. For biodiesel, there's some concern that it might cause both short-term or immediate effects on the performance of these devices, and also concern about long-term durability impacts. Studies to date have not shown any negative short-term effects. We generally see these devices performing the same with B20 as with conventional diesel. And there's some evidence that biodiesel may improve the function of diesel particle filters by increasing the reactivity of the soot and lowering the temperature required for regeneration. So the remaining concern is really the long-term impact of biodiesel on these devices, especially for heavy-duty applications where the defined useful life is 435,000 miles. And most of this concern is related to the potential for there to be low levels of metals in biodiesel, sodium, potassium, calcium, and magnesium, which could lead to high levels of ash accumulation in the particle filter or some chemical deactivation of the SCR catalysts, particularly if the metals were present at the spec limit, which is 5 ppm for sodium plus potassium and 5 ppm for calcium plus magnesium in the B100. Now, what we find in our biodiesel quality surveys is that the high-quality biodiesel samples that meet all the other spec requirements actually have very low levels of these metals, typically below 1 part per million. But if we were at the spec limit, the levels of metals may be of concern, and this is a very active area of R&D here at the National Renewable Energy Laboratory, and I know at several of the engine and catalyst manufacturers as well. And so with that, that concludes my remarks for today, and as we go forward with the webinar today, if I can answer any questions about what I've said, I'd be happy to do so. Thank you.
Thank you very much, Bob. And that's a great segue for a reminder that you can submit questions at any time during this presentation using the technology in the lower left-hand corner of your screen, and we will get to those towards the end of the session today. Just a quick clarifying question. Someone asked what OEM stands for. That stands for Original Equipment Manufacturer, and hopefully that helps clarify that. Thank you for that setup, Bob, and the framework for a broad understanding of biodiesel quality and production issues. Now we'd like to move into some of the user experiences that are out there, and we're delighted to have with us today Hind Abi Akar, who is the Fluids Engineering Technical Expert in the Specialty Products Business Unit at Caterpillar. And she comes to us today from Mossville, Illinois, not far from Peoria. And Hind, we're delighted to have you with us and look forward to learning more about what happened during those 2 million miles.
Well, thank you, Alan, and good morning, everybody. What I will be giving you here is a brief summary of a study that was done basically to answer some of the questions that Bob raised as to the practical use of biodiesel in actual applications. This is a field validation of B20. And again, as mentioned earlier, the B20 use is increasing. So this study was meant to answer some of the questions of the applicability of B20. So the goal was to demonstrate the practical use of biodiesel in an on-highway trucking application. So basically, what we were looking for here is the feasibility, the practice, the issues, and the implications on the on-highway trucks that use B20 in this study. This was definitely a collaborative effort, and a lot of organizations and companies participated in making this study a success. The study design, which actually was probably the longest study of its kind of this level of biodiesel, had 20 total trucks, 10 of which were a control, and these were the ultra-low sulfur diesel fuel, and 10 were the B20 biodiesel fuel. In each group, there was one 2007 model engine, and the rest were 2004. The importance of the 2007 model is that it has after-treatment emission devices, particularly the diesel particulate filter, which also Bob talked about it a little bit. The trucks were matched in pairs, and they all had similar routes, similar design. One important thing to note here is that all of these had new engines, and these were Caterpillar C13 engines, which means that the implication of the history of the engine was removed in this study. The study design, there was a lot of data collection, significant. On a weekly basis, there were downloads from the trucks to understand their idle time, their speed, their fuel economy, the distance, so on and so forth. On a monthly basis, the fuel was tested. Oil analysis was done at the maintenance intervals. Maintenance records were kept meticulously of all costs related to the study. And when the study finished, we conducted hardware analysis. We tore down few engines and looked in detail at the parts. Again, the study design, the fuel was mainly soy methyl ester. So it was an SME. It was provided by a Renewable Energy Group, which is a BQ 9000 producer, and that's very important too. For a small portion of the study, 20% animal tallow biodiesel was used. I also should mention that this study went through more than 2 years, from October of 2006 to June of 2008, and this means that it went through 2 harsh winters. And those who know the Midwest here, you know that we get very, very cold climate. So it's a significant challenge to see how biodiesel works in the cold winter temperatures. This is one of the practical aspects of applying B20 biodiesel, and a challenge really. I put here those graphs to show that in trying to reduce the plug point, which is the cold temperature applicability of the B20 and the ultra-low sulfur diesel, this is important to know for practice. The results that we saw here is that in using 6 commercial cold flow improvers, which are typically used with diesel fuel, we noticed that higher concentrations had to be used with biodiesel, and some of those that were successful in diesel did not really work well in biodiesel. And that's something important to keep in mind. So if you're using biodiesel, you need really to try which control improvers work best for you. In terms, again, of winter driving, the issues that we saw were basically filter fouling, fuel filter fouling, plugging, that is. There was no fuel gelling, probably because it was blended well. I also want to say that the fuel was very, very controlled. The trucks only fueled centrally, so there was no fueling on the road, so that we know exactly what the fuel was that went into the trucks. I'm giving you here some of the numbers to show the difference in fuel fouling in the filters that were used. Some of these were preventive, that is, they anticipated fouling. Some of them were really fouled filters. What did foul the filters? Gas chromatography analysis showed that these were completely saturated monoglycerides. And we will have a report that details exactly what the chemical composition was. Looking again at, this has a number of information that I will refer to. First of all, the miles per gallon, or the fuel economy of the fuels. We know that biodiesel has a little bit less BTUs, so it has less energy, which has implications on the fuel economy. You notice sometimes there was absolutely no difference, sometimes there was some difference. Overall, looking at total miles per gallon, there was really no significant difference. I want to point here to the bottom symbols here. These are the filters. They were unscheduled filters. So the solid symbols indicate the fouling. The others indicate just preventive maintenance. And you see that biodiesel significantly had more filter fouling. Probably this number here in November of 2008 was probably it wasn't winterized well. Looking at fuel economies is very interesting because if you look at just drilling through a lot of data, you see that actually there isn't much significant difference between the two. But if we keep drilling into the data and use average, weekly average, we see that there was a difference appeared to be about 2.5 to 2.25%. However, important to note that, and this is the challenge in looking at fuel economy in any application, that the driver impact was 18 to 23%. So this impact here becomes a little bit small compared to what the driver impact is. Maintenance record, meticulous account of maintenance records of all the costs associated with the trucks showed that basically there was no significant maintenance cost. The only difference was the fouled filters, which was about 3 times higher cost for B20. Engine oil impact, that's again another very important question for the industry and for those who are using biodiesel. We notice here that there was actually no impact. The maintenance intervals remained the same, wear metals and all the aspects of the oil remain the same. I want to state, though, and want to be clear, that these are very much dependent on the engine model. So in this study, this was the result. I encourage anybody who uses biodiesel to certainly use oil analysis before determining maintenance intervals. Again, we looked at engines. We looked at 2 pairs from the 2004 models and one of 2007. Looking at various hardware components, I'm giving you here some important components. The hoses, there was no adverse effect, but it's important to mention that these were FKM hoses, so they were biodiesel compatible up to this blend level. Intake valves, exhaust valves, there was no difference. One of the core engine components, the piston rings and liners, we saw that there was some increase in the deposit, slight increase in the deposits of the pistons in the B20 in the 2004 model. And these, however, they can be attributed to engine variation. They were very small differences. Within these differences, the deposits in the top land and top group were slightly higher, but intermediate group was lower. Again, for these two engines that we looked at. For the 2007 models, we did not see any difference. Again, another very important applicability point for biodiesel is the injectors. And these are basically the front line for any impact of biodiesel. For these engines, we took two sets of 6 injectors each, and we looked at them in every possible way in terms of performance, discharge, timing, peak, injection pressures, features of the various components of the injectors. And we saw both were very similar. We could not pick out differences specifically related to biodiesel. They were where we expect them. At the mileage, these trucks had 225 to 250 miles on them. And we did not see also, important to state, no varnishing or deposits on the seating band. However, there was one difference in the injectors. The tips of the B20 injectors had continuous layer of combustion products built up. It was in the sac and up to the edge of the orifice hole. However, no impact on performance was noted. This is here detailed. You see the injectors here. And again, you see the combustion products, combustion layer. At this mileage, again, there was no performance implications. We noted this because we looked at these at high magnifications and very, very closely. It's important to watch the long term, maybe at the 500 miles, 500,000, or however, it's important to keep an eye to see what the implications long term would be. Diesel particulate filter. This is the after treatment device that is also of key importance to the applicability of higher blends like B20s. Note that we looked only at one diesel particulate filter, so this is one data point. And as we expected, we noticed that there is 19% increase in ash accumulation in the diesel particulate filter. Cleanability was similar. So overall, we have a lot of positives. This was definitely a successful demonstration of using of B20 that was dependent on the management of the fuel and the overall management of the study and the fueling and having winterized fuels and knowing what to expect. So maintenance, fuel economy, engine hardware all did not show any negative impacts. The only thing that we can say is negative at this point, and we don't know the long-term implication, is the diesel particulate filter ash. Again, this is another, we need to watch for long-term implications. From this study, what we can recommend is that for biodiesel to routinely measure the phosphorus, alkali, and alkaline metals, because then, which is enhancing the BQ 9000 program, basically. It can allow us to model and anticipate what will happen with after-treatment devices. The other thing is we definitely need to have standardized specific biodiesel-specific oil analysis, because at this time it's still dependent to look particularly at biodiesel in the oil, dependent on the savvy of the tests in research labs. And this needs to become standardized. And that concludes what I have, and I appreciate your time.
Thank you very much, Hen. That was very instructive, and I think all the participants would share the view I have of being able to see the injectors and the different components visually like that helps really frame an image of some of the impacts of use of biofuels and help made some of your remarks very clear. I'd like to move on now to our next presenter, who is Walter Putz. Walter is Director of the Group Research for Mercedes-Benz Cars, Certification, Environment, and Regulatory Affairs for Daimler. And Walter is coming to us today from Stuttgart in Germany. Welcome, Walter.
Thanks, Alan, and thanks also to Kristen for providing this platform to discuss biofuel operation on diesel vehicles. And let me talk a little bit about small diesel vehicles first. I mean, the population of small diesel vehicles in the U.S. is still small, but it is growing continuously. And the three German OEMs that I am representing in today's webinar, Audi, VW, BMW, and Mercedes, all three have clean diesel cars and light trucks on the market that not only meet the most ambitious emission standards, but also demonstrate excellent fuel economy and accordingly low CO2 emissions. Also represented in my presentation today is Bosch, one of the major fuel system suppliers, as you know. And all of them see some need for discussing how to proceed with biodiesel operation of light-duty vehicles in the U.S. market. And I'm just talking about light-duty vehicles only. Following my content list, let's first have a look at the regulations and the incentive programs. On the federal level, the Energy Independence and Security Act requires the production of biomass-based diesel fuel to further increase. And what you see on the right-hand side, in addition, in the individual states, a variety of regulations and programs exist, including some incentives that support the production and sale of biofuels. And I think the most famous one is the one in Illinois that has provides a tax incentive, and therefore B11 is the predominant diesel fuel in Illinois. Diesel fuel specifications and biodiesel labeling. Since 2008, revised standards exist that include specifications for B5 and for B6 to B20. And the B5 to B20 specification requires an oxidation stability of 6 hours minimum. In comparison, the European spec requires 20 hours at the minimum. And according to what we know, the specs are not mandatory for biodiesel producers in the U.S. Labeling requirements has been implemented in 2008, and as a result, the customers today know when they fill biodiesel in the tank. This is some progress. A non-compliance penalty will be imposed if fuel station owners fail to label. Now let's have a look on some fuel survey data that we collected in 2008. This slide shows data from a survey being conducted by German car manufacturers in last year. On the left figure, you see the oxidation stability in the most cases was not just below the European B7 specification, but 32% of the samples did not meet the new, and with new I mean the 2008 specification for B6 to B20. On the right picture, you see the water content was always below the Astm spec, but also in several cases it would not meet the European B7 standard. Also, what you can see, there is a tendency for oxidation stability and water content getting worse with increasing blend rate. What can I say about durability tests and field issues that we have seen with biodiesel operation? Before we now look at the test and field issues from vehicles being operated with biodiesel, let me just emphasize that the risk for having some issues with engines or engine components resulting from biodiesel operation depends on a variety of parameters, which are primarily production and storage of the fuel, environmental conditions, and a major one is the temperature, and also the operation cycle of the vehicle in customers' hands. Therefore, as an example, heavy truck operators may have totally different experiences with biodiesel operation than a private passenger car owner. What you can see in this slide, some unfavorable fuel properties, production shortcomings, and remaining deficiencies in the specification may create issues with biodiesel operation. As a result, we see fuel filters being clogged, fine sticking and corroded fuel system parts, particularly after standstill periods, and we find injection nozzles being coked and deposits on the injector. The blend rate is the other major parameter. Primarily engine oil dilution, sludge in the engine oil and on engine parts, and deposits on piston rings and in the EGR system usually increase with increasing blend rate. As the light-duty vehicle fleet in the U.S. is still relatively low, we do not have a broad basis of statistical data, but a number of serious issues already identified. And as an example, what you can see in this slide, vehicle durability tests with a B20 fuel show frequent fuel filter clogging, and frequent in this case means every 3,000 to 25,000 miles. We also have seen high-pressure fuel pump parts failing at low miles with B100 use. And as the next page demonstrates, an engine in customers' hands was completely damaged as a result of severe sludge formation in the oil. The engine had run with biodiesel. We don't exactly know what he had in the tank, but we have some clear data or indication that he was running with biodiesel. Now, what does the OEM landscape on biodiesel operation look like? This market analysis demonstrates that no car OEM has approved the use of B20 today. Moreover, the approval for use of biodiesel in light commercial trucks goes along with restrictions in the use or some other requirements which would not be appropriate for private car uses. Also on the next slide, most of the heavy truck OEMs have not approved B20 use as of today. Now, what is the position of the fuel system suppliers? The common position statement of the major fuel suppliers from 2009 expresses the concerns they have with low-quality biodiesel or with fuel that is not successfully evaluated. Therefore, fuel system suppliers usually don't take responsibility for damage on fuel systems resulting from low-quality biodiesel operation. What are now the requirements for quality improvements of biodiesel? The German car OEMs and the fuel system suppliers see some need for quality improvement. Major parameters that need to be considered are the oxidation stability, the percentage of methyl esters with double bonds, the purity and the cold soak filterability. And moreover, from our point of view, a monitoring system that ensures a certain standard should be implemented. We also believe there is some complementary biofuel options that we need to consider. For example, vegetable oil or biomass to liquid. And from our point of view, there is not one exclusive source of biofuels. There are opportunities for different kinds of biofuels that are compatible to each other. And a fuel with biodiesel and HVO can be designed to have a high bio content and excellent properties for the engine as well. Let me conclude now. Today's diesel engines with sophisticated emission reduction systems require clean and high-quality fuels. We believe there is significant need for improvement of specification and production process of biodiesel, and from our point of view, monitoring of the quality of the biofuel being sold should be considered. Today, the German car OEMs approved the use of B5 only according to the Astm D97508, which actually is ultra-low sulfur diesel with a maximum 5% FAME. And similar to Europe, all of us will be happy to approve a maximum biodiesel blend level of 7% FAME if the overall quality parameters have been further improved. And at the end, let me emphasize, we do support the development of B20 or even higher blend rates. But the rate increase needs to come from paraffinic and renewable high-quality biofuels, like, for example, hydrotreated vegetable oil or biomass to liquid fuel. And also, significant testing is necessary in order to ensure reliable vehicle operation over the wide range of operation conditions that we see with small diesel vehicles in customers' hands. Thank you for your attention.
Thank you very much, Walter. That was a very informative presentation, and you've now heard results of a 2 million mile experience in heavy-duty commercial trucks, and you've heard some perspectives from manufacturers and suppliers that are producing the cleanest new generation of diesel cars in the world. And now we'd like to turn to the sector which will ultimately make it all happen in terms of a expanded distribution and availability of biofuels in the U.S. and we have with us today Rich George, who is the Distillate Technical Engineer for BP, and he is coming to us today from Naperville, Illinois. So welcome, Rich.
Thank you, Alan, and thank you to everyone attending this webinar. Making it all happen, a fuel provider's perspective. We're going to talk about the challenges of making the fuel available, the fungible infrastructure, retail stations, dispenser labeling, then maintaining quality. We'll talk about the Astm standards and precipitates above the cloud point. And then we'll also talk about the impact of state and local biodiesel mandates, things like Minnesota, Portland, Illinois. The first thing is the system is fungible, and that means that diesel fuel is a commodity. And, the refineries, the pipelines, the terminals, the transport haulers that you see on the road, and the retail sites all may have separate ownership. Back in the day, there was integrated oil companies that owned all these things, but we're moving away from that. And so it makes it a challenge because a major oil company, we may have the refinery, but we may not have the pipeline or the terminal. And so we all have to work together, and that's where things like ASTM become important because we need to have good agreement on what the specifications for biodiesel should be. One of the biggest challenges or drivers into how we distribute the fuel is that biodiesel is not allowed in pipelines that carry jet fuel. And the concern there is that the jet fuel will trail back or get mixed in with the jet fuel and cause the jet fuel to be off spec. And as everybody's aware, jet planes don't pull over to the side of the road. So protecting jet fuel is a high priority. So the pipelines have not allowed biodiesel to go in there. There are a few that do, and those don't carry jet fuel. But for the most part, biodiesel is not moved in pipelines. And this is kind of similar on the gasoline side with ethanol. Ethanol is not moved in pipelines. So what happens is the biofuels, the ethanol and the biodiesel, are typically blended at the distribution terminals. And I think most people have seen distribution terminals. Those are, you sometimes see them on the side of the road, the big white tanks, and they'll have 100,000 barrels of fuel in there. There is a project going on right now to approve a small amount of biodiesel into jet fuel, 100 parts per million. That amount will be considered to not harm the jet fuel, and once that happens, then it will facilitate being able to move blends up to B5 on the pipelines, and that'll really open up the infrastructure quite a bit. At the terminals, it requires heated tanks and heated trace lines for the B100, and that really has to do with the cloud or the freeze point of the biodiesel. A soy biodiesel will freeze about 32 degrees F, where something like a tallow biodiesel might be higher than 50 degrees F. So the tank has to be heated, and all of the lines going to the load rack and everything need to be heated. And to do that at a terminal, it literally can cost millions of dollars. And that's probably one of the biggest barriers to setting up a terminal. Well, it is the biggest barrier to have proper inline blenders. When ethanol and gasoline are blended, they get blended. There's two lines going to the load rack, and as the fuel is put onto the transport truck, they're blended together. That's the best way to do it. That's the way we'd like to do it with biodiesel, but the cost just makes it not worthwhile when you're doing low volumes. So what happens is most biodiesel blends are splash blended, and that term has to do with splash blending it into a truck where a transport will pull into one terminal and pick up diesel fuel, and then they'll go to another terminal and pick up the biodiesel or vice versa in the order. In those situations, you don't always know where the B100 is coming from. If it's our terminal, we know where the diesel fuel came from, obviously. But if somebody is a jobber of ours, and I guess I should point out that most of the stations that we have, and same for other big oil companies, we don't own them. They're franchises, and they're owned by what we call jobbers and dealers. And if a jobber is blending biodiesel, we may not know where that biodiesel is coming from. So biodiesel blends at retail. One of the things about biodiesel is it holds more dissolved water than diesel fuel. And when I talk about dissolved water, that's the amount of water that a fuel like biodiesel can hold before it starts becoming hazy. If you see haze in the fuel, you've got free water. regular diesel fuel can only hold about 50 parts per million, maybe 100 parts per million of water. Biodiesel can hold about 1,500 parts per million before it starts to get hazy. And then the biodiesel blends kind of hold, a B20 or lower will hold a similar amount of diesel fuel, again, around 100, maybe a little bit more than that. Typically, that's not a problem. If you get excess water in the system, that water will turn to haze, and then those water droplets will eventually drop to the bottom of the tank. And if you look in the bottom of any diesel fuel tank, you'll find water on the bottom to some extent. You'll find the same thing with biodiesel. So water is not nearly as big of a problem. When you're talking about ethanol and gasoline, water can be a huge problem for ethanol. But with biodiesel, it's typically not nearly the problem that it is with ethanol. Equipment compatibility. UL is Underwriters Laboratory. They approve a lot of the dispensing equipment. You may be familiar with them. They approve a lot of electronic devices and stuff. If you flip over your computer, you might see a UL label. Well, they need to approve the dispensing equipment for retail sites before the fire marshal of that state will sign off on the equipment. And to do that, they do all kinds of testing, and then they approve it. UL has approved biodiesel up to 5% in most of the retail equipment that's out there. They haven't gone beyond that. So that's one of the reasons you haven't seen a lot of the big oil companies going to anything higher than a B5. It's one of the things, in our retail sites where we can't dispense it. Each state has a different law, so things are different for different states. One of the big concerns with retail dispensing equipment is the seals and gaskets inside. Biodiesel has a little bit different properties than diesel fuel, and it may cause those seals to leak and swell up in different manners than they do with straight diesel fuel. And then the next big topic for biodiesel blends at retail is labeling requirements. Most states follow the FTC guidelines, which does not require labeling for up to B5. But B6 to B20 blends are required to be labeled, and there's an example of that label. They're usually a blue and black square like that, about the size of the octane sticker for gasoline, and they'll say it contains biomass-based diesel or biodiesel in quantities between 5 and 20%. Above B20, then the FTC requires that the actual blend percentage be labeled on there. And then there's the issue of branded and unbranded, and that has to do with if you go into a retail site, the diesel fuel and the gasoline are typically branded the same as the retail site. But if the owner of the station is blending a biodiesel blend and he's using biodiesel that's not supplied by the branded big oil, then he's going to sell that fuel as unbranded. And the pump should have a label on there that says something like, "Notice not a BP product." And in that case, then, if you do have any issues with that fuel, you would need to approach the owner of the station. And that's unbranded fuel. Typically, it should be clearly labeled on the pump, whether it's branded or unbranded. So it's something you want to watch out for. ASTM standards, some of the other presentations touched on this, so I won't go too far into detail. Just want to mention that ASTM is a consensus process. It's made up of oil companies, biodiesel producers, engine manufacturers, general interest groups. There's the pipeline will have representatives there. State regulators will be there. They all come to an agreement, and the results of that process are coming up with standard specifications. D975 is the big one for diesel fuel oil. D6751 that's been mentioned is the standard specification for biodiesel blend stock. Most states have laws requiring ASTM specifications, but not all states. And some states will modify the ASTM specifications a little bit. There is no federal law for diesel fuel, and there's no federal law for biodiesel. It's all done at the state level. And there are a few states out there that don't have any fuel laws. Those types of states, though, typically the ASTM specifications still kind of govern what's going to be made, because nobody's going to make a fuel that's acceptable in one state and not another. So for the most part, all of the fuel in the U.S. meets D975, all the diesel fuel. The other specification, 6751, Steve Howell, who's going to be joining us later, wanted me to point out, and it's an excellent thing that he did, that biodiesel not meeting 6751, even by a little bit, can cause problems. Meeting the spec is critical. And we've seen that. A lot of times when there's biodiesel situations out in the marketplace, when you really get down and look at them closely, you find out that it's biodiesel not meeting 6751. And technically, if it doesn't meet 6751, it really shouldn't be called biodiesel. When the fuel meets 6751, for the most part, we don't have problems. One of the problems that we did run into, was mentioned by some earlier presenters, has to do with saturated monoglycerides and some other impurities. And the cold soak filterability test was recently added to 6751 to address some of those issues. We'll talk about that on the next slide. One of the big things was this B5 now being incorporated into D975 diesel fuel. That means that a B5 blend is technically diesel fuel. And somebody selling diesel fuel to you, it may have 0, 1, 2, 3, 4, or 5% biodiesel in there. And that's caused a little bit of difficulties out there for some people. If somebody buys diesel fuel and they want to blend B5 into it on their own, it may already have 5% in it. And 5 on top of 5 may cause them to make something that, well, it'll be a B10, and then therefore it would have to meet a different specification and different labeling requirements. People also worry that they might be getting fuel from a pipeline or somewhere that has biodiesel in it when they don't want it. So there are some contracts being written where people will specify that their diesel fuel be straight diesel fuel and not be up to B5. And then the last specification is D7467, and that's the biodiesel blend specification. The cold soak filterability test, it was designed to catch precipitates above the cloud point. There was some problems with filter plugging at relatively warm temperatures. And diesel fuel typically has a cloud point of 5 degrees F, maybe up to 15 degrees F. That's where you first start seeing the wax crystals coming out. But people were running into problems with some biodiesel blends where they were having precipitates drop out of the fuel at temperatures well above the cloud point. And so this cold soak filterability test is a performance test to catch those. And just briefly, you take 300 mils of the B100, you cool it 16 hours at 40 degrees F. And that's close to what a refrigerator is. So it's not a real cold temperature, it's a cool temperature. Here in Naperville, 40 degrees F would be a nice warm day in the winter. So that 16 hours at 40 degrees F is the cold soak part of the test. The sample is allowed to rewarm back up to room temperature, and it's filtered through a 0.7 micron filter. It needs to get through that filter, the 300 mils, in 360 seconds to pass the test. If the biodiesel is going to be used in a 10-degree Fahrenheit or colder climate, then it needs to pass 200 seconds. And this cold soak filterability test did remove much of the bad B100 in the marketplace. A lot of the problems that we saw in Minnesota in the first year, I think, can be traced back to fuel that didn't have real good cold soak filterability times. Now that the specification's in place, we've seen the amount of problems go down dramatically. It doesn't, however, catch all the problems. Here in Naperville, Illinois, we're in Illinois, we do a lot of B11 blending, and it has to do with the tax break. And I went out one last winter, and I grabbed 8 samples, and this is after the cold soak filterability spec was in place. Grabbed 8 samples, tested them. 3 of them were straight diesel, 5 of them were B11 blends. After 24 hours in a refrigerator at 35 degrees F, 3 of the B11s had precipitates. After 48 hours, they all did. And then leaving the samples in there for a week, none of the diesels had any precipitates. So it's coming from the biodiesel. And I've got a little video here. Kristen's going to help us. Basically, this sample was put into, it's a B11 sample bought at a retail site here in Illinois, put into the refrigerator overnight at 35 degrees C. Hopefully it's going to show up well here, but if you give it a little swirl, you can kind of see these precipitates rising up off the bottom. If anybody wants to kind of evaluate their biodiesel, it's a simple test. I'm not going to recommend you put it in your refrigerator with your food, but if you can put it somewhere where you can get it down to about 35 degrees C or F, or colder, let it sit overnight, and then take a look at the bottom and see if you see anything on the bottom. Give it a little swirl and see if you can see that stuff rising up off the bottom. So we'll move on to the next slide. What those things are is, it was kind of mentioned in Hin's presentation, they're saturated monoglycerides, and they're a byproduct of biodiesel production. All biodiesel has it to some level. It's kind of feedstock dependent when you run other feedstocks. Soy doesn't have a whole lot of the saturated monoglycerides in there. Tallow has more. It kind of goes back to the saturation levels of the feedstocks. Soy oil is about 15% saturated fatty acids, where tallows are more like 45%. And there's kind of a correlation between the saturation level of the feedstock and the biodiesel to the amount of saturates that are in there. Tallow will be a solid at room temperature, where soy biodiesel is a liquid. So catch up to that slide. These monoglycerides that fall out, again, it's the saturated monoglycerides. They've been linked to causing some filter plugging in dispenser filters. They don't cause as many problems in vehicle filters. The vehicles typically have a recirculation loop where fuel goes up to the engine, and then it goes back to the fuel tank, and in that process gets warmed. And as the fuel warms up, and if you do have some saturated monoglycerides trapped on the filter, the fuel system's pressure and the warmth of the fuel will typically force those monoglycerides through, and they don't seem to cause problems in the engines. So for the most part, this hasn't been a huge problem, but it is a problem that's still out there. We do see some dispenser filter plugging from time to time when it gets very cold, and we've seen some engine filter plugging engine fuel filter plugging. And it's a little bit of a problem on newer vehicles because they have tighter and tighter filters. One of the things to meet the emission requirements that are coming up, the ones from 2007 and for 2010 are requiring high-pressure common rail, which is requiring higher pressures, which is requiring tighter tolerances and finer filters. So we do see that older vehicles can tolerate the saturated monoglycerides better than the newer vehicles. And ASTM's formed a working group to address this situation. The biodiesel producers and everybody working with ASTM has done a great job in trying to address these situations when they come up as quickly as we can to have a biodiesel fuel that's more fit for purpose. And then briefly we'll go over the state mandates and some incentives. Minnesota State, I mentioned, had a B2 mandate that started in 2006. It recently moved up this year to B5. This will be the first winter for B5 in Minnesota. In the future, it'll go up to a B10 and a B20. In the winter, though, Minnesota will still stay at a B5, so they'll have like a B20 in the summer and a B5 in the winter. Portland, Oregon is at a B5. The rest of the states at a B2. Washington State has a 2% of the diesel pool, so not every drop has to be B2. If somebody sells a B20, they can use that to average some straight diesel fuel. Pennsylvania's got a B2 mandate coming up in January 1st, very soon. Massachusetts has a B2 mandate coming up July 1st. And then the big thing out there is the Illinois tax incentive. I mentioned that here in Illinois we have a lot of B11. That's because the state has no sales tax when you blend greater than 10% biodiesel into diesel. That's where the 11 comes from, if you're wondering why we have such a strange number. I read some report that said about 40% of all the B100 in the U.S. goes through Illinois, so the bulk, there's a lot of biodiesel blending in Illinois. And I have a diesel pickup truck, and just from what I've seen going out to retail sites around Illinois, that probably about 75% of the retail sites in Illinois are dispensing B11. And that's easy to see because they all have to have that FTC label. And a little more on state mandates. The RFS2 sets the bar really high for biodiesel blending volumes. The state mandates that are out there, those volumes that you blend, like what we do here in Illinois and what we'll be doing in Pennsylvania and Minnesota, they'll all count towards our RFS2 obligation. So the state mandates won't make a net increase in the amount of biodiesel that's blended out there. We're going to have to do all the state mandates and then some to meet RFS2 once it goes through. But what the state mandates do is they dictate where the blending will occur. Obviously, in a state like Minnesota where they have a B5 mandate, we have to blend there, and every drop has to be B5. And all of our competitors have to be B5. So what they do is they wind up making the market consistent, at least in those areas. In other areas where you don't have a mandate, if one company chooses to sell biodiesel blends, the guy across the street may be selling straight diesel fuel. And there's pros and cons to that. It gives the consumers a choice when they have an open market like that, but then, if there's an incentive, the guy that's getting the incentive is kind of at an advantage to the guy who's not getting the incentive for blending the biodiesel. So, in conclusion, biodiesel blending for oil companies is very challenging and it's not straightforward. The rules don't seem to be as straightforward as ethanol blending. All ethanol blending happens at terminals where biodiesel blending just isn't as well defined. The Astm standards have helped ensure quality by reputable producers, and we recommend you always insist that your biodiesel meets D6751. There's still some quality concerns left to correct, and everybody at Astm is working on that. And RFS2 and state mandates are really going to heavily influence biodiesel blend availability in upcoming years. The economics aren't really there for biodiesel at the moment, and if the RFS2 mandate goes through, you're going to see a lot more biodiesel in the marketplace. I'd like to thank everyone. That concludes my presentation, and I look forward to any questions.
Very good. Thank you very much, Rich, for that informative presentation. And as always, we're happy that the video worked, and that was also instructive to look at the filterability under cold conditions there. Well, thank you, everyone. And now it's time for our question and answer period. And just a reminder that we have been accepting questions all along in the lower, or you can submit them in the upper left-hand corner, and we're going to get to as many of those as we can within the allotted time, and we have about 25 minutes or so to do that. Let me start by addressing a couple questions that were asked at the outset, and the questions of will these presentations be made available and where. Yes, they will, and we'll provide you with the instructions on that at the end of today's session. But you will have access to the presentations as well as the recording of this presentation, this entire event. So with that, let me go then to some of the questions that have been submitted thus far, and I'd like to start with some of the broader questions that I think get to Bob's presentation that started all this. And one of the questions comes: what is the anticipated production of biodiesel in 2010, and what are additional volumes from heating oil? What's the question?
Well, this is Bob McCormick. I think the anticipated production in 2010 depends pretty critically on how the EPA rules with respect to the renewable fuel standard and its implementation in 2010. The best case scenario for the biodiesel producers could be as much as 1 billion gallons in 2010, but I would hesitate. I would be very reluctant to actually predict what's going to happen in 2010. As for the volumes going into heating oil, I don't know that number off the top of my head. Perhaps Steve knows that.
That's right. I should recognize Steve Howe, who's the Technical Director of the National Biodiesel Board, who is now joining us for the Q&A part of today's session. Steve, welcome.
Thank you. Thank you very much, Alan. And the heating oil industry has come out with a position statement that they would like to see 2% biodiesel voluntarily in heating oil next year. So the heating oil market is about a 7 billion gallon market in total. So somewhere around 100 to 150 million gallons or thereabouts is probably a good estimate for how much biodiesel would be in heating oil potentially next year.
Okay, good job on that, both of you. There are a couple of questions relative to state policy, and I want to raise one of those now. What does the future hold for limited distribution states, as this participant has labeled it, such as Florida and Georgia? We want to use biodiesel, but limited in a biodiesel availability. And would any one of our presenters like to comment on that one?
This is Rich George. Florida and Georgia have a fair amount of petroleum terminals that are waterborne. And so I think you'll be able to see some biodiesel blends, possibly like B5s, being blended on ship transports and brought to those stations. In those cases, they'll probably come in as a B5 blend. So it may be that when those fuels are brought to retail market, though, they might not be labeled in that way. I can see where there will be some B5 blending. A lot of the fuel that comes into Florida comes out of Texas, and it can be brought over on a ship, and they may blend the B5 there. You lose flexibility when you do that, though. When you have a terminal system, you're able to kind of dial up the rack injector to go from B2 to B5 all the way up to B20. When you blend it on a ship and bring it in, you don't have that flexibility. So I think you'll probably see a fair amount of biodiesel in Florida and Georgia as B5s, but, well, it'll be there. I don't know if you'll see it because at the retail pumps it may not be labeled.
Okay, good response there, Rich. While you're there, a participant had a question about the final point that you made about how uneconomical is it for biodiesel, and how much will it raise? How much will the mandate raise prices?
Well, if biodiesel blends cost any more than the diesel fuel, then there's no reason to blend it. And it gets the dollar credit, but even with the dollar credit, I think we've seen for a few years now that biodiesel has been more than diesel fuel. If it drops below diesel fuel prices, even by a few pennies, then there's going to be a lot of people interested in blending it all of a sudden. And that's where some of the feedstocks become important, because some other feedstocks like palm and tallow tend to be cheaper than soy. And if they have the ability to come down below diesel prices easier than soy. And so there's a lot of interest in blending tallow biodiesel, although it has some cold weather properties that make it not blending in the winter. But in the summer, you'll see a lot of tallow blending.
Okay. A general question here. How long will we have first-generation biodiesel transesterification? Question. What are your views on second- or third-generation biodiesels? And I'd like to open this up for all the panelists. I think there are some different perspectives here. Let's start with you, Bob.
Well, my feeling is that we're going to move to a world where there's biodiesel made by transesterification, but also some other biofuels made from lipid feedstocks made by hydrotreating and co-processing. And it's really going to depend on location and the exact situation. For example, in areas with a lot of petroleum refining capacity and a lot of hydrogen production capacity, maybe it'll make sense to make a hydrogenation product, but in other areas, transesterification will continue. And really, the transesterification process has very low capital costs compared to hydrogenation, so that's something in its favor. To have comparable costs with hydrogenation processes, you have to be at much larger scale, way more than 10 times larger scale.
Okay. Other presenters have questions about that? What are the views on the second or third generation biodiesels?
This is Hind from Caterpillar. And we believe that, just like Bob said, there will be other processes coming to transform, whether it's biomass or the vegetable oils, into non-ester fuels. But we believe also that biodiesel will be, we anticipate that it will be around for a while, and also we are looking globally. And just like Bob mentioned, that biodiesel has a low capital investment, and that really encourages the using of local crops like soybeans or palm or others to generate the first generation, which is the esterified biodiesel. So we will see some transition, but I believe for the coming future we keep an eye on ester, whether in the U.S. or globally.
Alan, this is Steve Howell. I've got a comment, if I could.
Sure.
I think one thing for everyone on the call to be sure that you're aware of is that biodiesel has a specific definition, a spec within ASTM, and it has to be the monoalkyl ester that Bob McCormick talked about. And with that oxygen group and with the ester group, you bring some very specific chemical and physical attributes to the table. Biodegradability, lubricity. You bring particulate reductions that aren't possible with just a straight hydrocarbon type fuel. So there are some technical advantages to biodiesel, it being the monoalkyl ester, that I guess we as the National Biodiesel Board foresee being advantages out to the future. You will see additional types of renewable oils and fats be produced into straight hydrocarbons that don't have oxygen, so you won't have some of those beneficial properties that the biodiesel brings to the table. And at the end of the day, it's probably going to come down to economics. Which process and what chemical and physical attributes are going to be those which are desired by consumers and produced, at the least cost with the high quality fuel. So we believe that we will see both moving to the future, but with biodiesel being a very low capital intensive process for a lot of the production plants out there, biodiesel is probably going to end up being the low cost option. So we foresee that being a fuel that's going to probably be out there in the foreseeable future. And with potential improvements in the types of oils and fats that we use, we may be able to get biodiesel which has cold flow properties and stability properties similar to conventional diesel fuel. So that the future, you could even see potentially more biodiesel as we optimize the types of biodiesel we use.
Okay. And Walter, would you like to comment on that?
Yes, let me talk about this a little bit. As I mentioned before, from an engine OEM point of view, the biomass from vegetable oil or biomass to liquid, this has some favorable characteristics for the engine. And as I mentioned, before, you can mix some components. That means several components can be blended. You can go to higher blend rates. And all this is, from our point of view, means that we need to go towards this direction. It means in the future we need to talk about or need to deal with fuels or bio fuels blended out of these components.
Okay. All right. Very good. Thank you. Let's see. Here's just a general question. Maybe this is something you know, Rich, or others may know. Is B20 readily available in Ontario?
I'm not familiar with the biodiesel availability in Ontario. I'm sure that it's available somewhere. I'm sure somebody has B100 tanks, a jobber that would be able to make up any blend that's out there. I doubt, though, that it's being sold at retail sites in any large quantities. A lot of times you have to look for kind of those, maybe a mom-and-pop kind of gas station where they're selling a lot of different types of fuel, like E85, and they'll have propane and kerosene. Those are the kinds of stations that you tend to find like a biodiesel blend, like a B20 at.
Okay. Here's another sort of general question for Rich and maybe others. What are the advantages and disadvantages of adding kerosene to B20 in cold months, other than a reduction in fuel economy?
Well, kerosene is going to lower the cloud point, and that's why people are putting it in there in the first place. A diesel fuel, like I said before, will typically have a cloud point of anywhere from 0 maybe up to 15 degrees F, and adding kerosene will lower that cloud point 3 to 5 degrees for every 10% you put in there. You'll see similar for the lower biodiesel blends. When you start getting into higher biodiesel blends, things above B20, you don't see quite the benefit from the kerosene that you do with straight diesel. So it will lower the cloud point and the operability point, again, about 3 to 5 degrees for each 10%.
Okay. Thank you.
If I may comment here very quickly. In one of the months in 2007, February, 40% kerosene was used in the 2 million mile haul study because there was a severe cold snap in the Midwest here. And we did not see anything like issues that were specifically related to the kerosene blending with the both bio or ultra-low sulfur diesel.
Okay, very good. Hind, while you're on the line there's a number of questions for you. relating to the presentation, and I'll just start with the first one here. What is the statistical certainty for each of the reported observations for ULSD as well as B20?
I should mention that the information that I gave is extremely brief. We will have a report out, and most probably an SAE paper, that will give you all the statistical analysis for the fuel economy, for the blending, for all the information that we have, the oil analysis. So there is a lot of statistical information and data that will come out in the report for this study.
Okay. Second question, was the filter fouling caused by wax particles or dirt particles from the cleaning effect of biodiesel?
These were only related to biodiesel. There was no cleaning effects because, as I mentioned, these were new engines that haven't seen a history of use before. And most of what plugged the filters was the saturated monoglycerides, the palmitic, steric, and another 20 carbon saturated monoglycerides. So these were not a cleaning effect. They were specifically fuel related.
Okay. Another one there. You're doing such a good job on these. What impacts could be expected with biodiesel blends and standby generators used at remote mountaintop radio sites?
That's an excellent question, and that's a question that we as manufacturers are working on, and as an industry also we are discussing, because long-term storage of biodiesel is certainly a concern. What I want to anybody who has gensets that is not sure if they have biodiesel or ultra-low, because up to B5 you may not be able to tell. We certainly encourage you, actually, we strongly recommend that you test the fuel, and then you test it at periodic testing. Monthly is recommended. So, and you look, when you test, if you have biodiesel blending, we definitely recommend that you test for acid numbers, for some other specific parameters, including the acid number, and that tells you if you have any deterioration of the fuel, because standby and emergency gensets are very critical. When you switch the button, these have to go, and you cannot afford to have any fuel that is degraded in these systems. So that will put some responsibility on the user to test the fuel. And hopefully, maybe within the industry, we can come up with an industry recommendations. At this time, look at the OEM recommendations.
Okay. One more detailed question here. After the initial switch to B20, did fuel filter fouling continue, or was that a one-time increase in maintenance costs?
It did continue, and we have a graph that showed that, and it was month-dependent. An important point, and I'm glad this point came up, that not all the B20 trucks had similar number of fouled filters. Actually, there was 3 trucks, 3 out of 10, which were responsible for half of the fouled filters. So it's interesting and makes it a little bit unpredictable. But since these trucks only ran at B20, they did not have a previous history of other fuel. It started showing up, and it was weather dependent also. And the plot, which the audience will have, will show them month by month the number of fouled filters.
Okay. And Alan, this is Steve Howell. If I could add one more comment to that.
Yep.
This was a test run up in Iowa and Minnesota and Chicago, so it was certainly, some of the coldest areas of the country. And since that test was actually completed, the new cold soak filtration test, which is intended to pick up the potential of some of these minor compounds, sterile glucosides, like Rich George mentioned, or saturated monoglycerides, which they found on some of those filters. The new cold soak filtration test was not in place at the time that this demonstration was run. So we would expect, for fuels that meet the existing cold soak filtration, for the number of filters to be even lower than what was in that particular test. So those additional controls that we put into place weren't in place yet for this test. They are in place now. So just wanted everybody to know that.
Okay, important perspective. Thank you, Steve. Walter, I have two questions for you relative to the Mercedes experience. The first one, are EN specs mandatory in Europe?
Yes, B7 is mandatory in Europe, and you also need to know it is part of the European Commission's CO2 reduction plan for 2012 to 2015. So, and the good thing is the biodiesel fuel is provided not like in the U.S. by, let's say, several hundred or maybe more individual companies. It's primarily provided to the market by the major oil companies. They have a pretty good reporting system in place, so that means usually the customer knows and the OEMs, engine OEMs know what biofuel is in the market, what quality. So this is something that we would appreciate to see in the U.S. as well.
Okay, and then another question, Walter. What are the statistical observations of component failure between ULSD and B20?
Yeah. Well, this is a little bit early to talk about this because, as some of you may know, with the recent technology, that means after-treatment systems for particulate reduction and NOx reduction, we don't have that many statistical data from the U.S. market. So what we have that means what we have seen before is a few examples from durability testing and first issues from vehicles in customers' hands. On the other hand, we have excessive data from the European market with different kinds of biofuels. So what we see in the U.S. now is a clear indication that we are running into issues in the market if quality does not improve according to what we believe is the appropriate specification. But again, broad range statistical data are not available yet. We are just collecting more data every month now, and I guess in a half a year from now, in a year from now, we will be in a position also to talk about broad range statistical data. It means all companies, BMW, VW, and Audi and Mercedes.
Okay, very good. Thank you. I have a couple of questions related to Rich, I believe, probably as a starter. The first one being is the Underwriters Laboratory evaluating B20 blends for approval.
I don't think they are yet. Steve Howell might know better. I think right now they're focused on doing dispenser equipment for E85.
Yeah, I can certainly update the audience on that issue. The National Biodiesel Board is working very actively with UL as well as other agencies that approve various piping, dispensers, underground tank systems, leak detection systems. The issue right now is that they have protocols in place for gasoline and diesel fuel, but they don't have any identified protocols in place to even do the biodiesel testing. So we're working with them right now to identify if there needs to be any different testing with biodiesel than there is with conventional diesel fuel, and get those protocols into place. And once those protocols are in place, then do whatever testing is necessary by the industry representatives who need to do that testing to get the B20 approvals. There don't appear to be any major obstacles other than getting those protocols approved and then actually running the tests. The big issues that have been identified are potential materials compatibility issues, especially with the higher blends. At B20 and lower, we haven't seen a whole lot of issues with diesel engines and the fueling systems thus far, so we don't anticipate that there's going to be a lot of problems there for B20 blends and lower. For blends higher than B20, we all know that there are certain hoses and gaskets which don't hold up well to pure biodiesel, and so if you want to store those type of materials, you're going to have to change, to a biodiesel compatible material.
Okay. Thank you for that additional insight, Steve. Another question related to the distribution. With separate ownership of refineries, terminals, pipelines, etc., who is responsible for meeting ASTM D975? So I think this is a very important question.
This is Rich. It's all of the above. The refineries will produce the fuel to meet D975, and anytime the fuel changes hands, everybody has an obligation to ensure that it still meets D975. And interesting of a thing, because if it's made on spec, the pipeline nothing should happen to it in the pipeline to throw it off spec. And ultimately, when it's at a retail site, most states have people that go out and pull samples randomly and to check to make sure that they're meeting the specifications.
Okay. Another question here, sort of along the same lines. If less than B5 is technically considered to be diesel, is it going to be allowed in the pipelines?
No, the pipelines will, they have their own set. pipelines will sometimes have specifications that are a little bit stricter than D975, and then the refineries have to meet their specifications, and they will explicitly say, no biodiesel. And I'm sure that they randomly check samples to make sure that happens. Once they get the okay or the approval from the jet community to allow up to 100 ppm, then they'll make the decision whether they'll allow B5 or not.
Okay. We have one of our participants has offered a piece of additional information relative to the Pennsylvania mandate that I believe you had on one of your slides, Rich, and he indicates that Pennsylvania announced that the new deadline for their mandate is May 1st, 2010, not January 1st. I don't know if you can, or Steve could confirm that or not.
I can't confirm it right now, but I can certainly look into it and confirm that in subsequent interaction.
Yeah,
Okay.
That may very well be. A lot of these mandates, by the time they first start talking about them till the time they get finished, can be a long time, and things change. So it may be May 1st.
Okay. Another distribution-related question. If B5 can be sold as ULSD, how can bioblenders be sure that they don't have a B5 when they go to blend B20, then ending up with a B25 blend?
Yeah, that's an excellent question, and that's a concern of a lot of the jobbers. They're going to have to confirm one way or another with who's supplying the diesel fuel to them, whether it has biodiesel in it or not. If it's coming off of a terminal that is being supplied by a pipeline that bans biodiesel, then they know for sure that they're getting straight diesel fuel. If they're buying, most people who are going to be doing the blending know where their fuel's coming from, and they can confirm with who they get the diesel fuel from, whether it has biodiesel or not. If they're really in doubt, then there are some biodiesel field testers out there. They're not cheap, but on the other hand, they're not really expensive as far as laboratory equipment goes, and they can test the fuel themselves.
I have just a general question here for the group. I wanted to ask about the question of enforcement, as this webinar has highlighted a number of what appear to be increasing use of biofuels in states as well as potentially at the federal level here in the not-too-distant future. And, Rich, you showed us a label of what the pump should look like if it has a B20 blend. And many of us in the diesel community have, in the last few years, lived through the transition to ultra-low sulfur diesel fuel and the very precise labeling requirements and expectations of that. If we're driving a new diesel car that requires the use of ultra-low sulfur diesel fuel, we seek out and look for dispensers and retailers that can deliver the quality of fuel that our new vehicle requires. And EPA is working with a number of us and shares information about the disparities in what's on the pump label and what's actually coming out of the pump at any given time. And still to this day, there are some variability within pumps being not labeled as ultra-low sulfur diesel fuel but dispensing it, which is probably not such a bad thing, but then pumps being labeled as having ultra-low sulfur diesel fuel but not meeting the spec. And this is now 3+ years after the implementation of ULSD. As we look towards greater use of biofuels, what's the role of enforcement here that folks that purchase a new Mercedes car, for example, or a BMW or a new diesel pickup truck that has an advanced emissions control system here in the U.S., what's the expectation that a consumer can have that the fuel that they're putting in their tank is the right fuel for their vehicle that meets the manufacturer requirements? How will they know that, and how can they have confidence in that? Because the label does not always indicate compliance.
Yeah, that's an excellent question. Sulfur is one of the few properties of diesel fuel that is handled on a federal level by the EPA because it has to do with emissions. And so there's a real robust program out there for testing and enforcement. You won't have the same type of thing with biodiesel blends. Biodiesel blending is going to be handled at the state level, and some states have aggressive programs out there where they test sites, and other states don't. Now the blue and black label that I showed you, that's a federal requirement. That's the FTC. So there is probably stricter penalties for violating that, although I'm not aware of the FTC going out and actually doing any testing. So being that this is a kind of a new market, biodiesel and everything, I don't think we probably need stricter enforcement out there. It might be, and again, it varies state to state.
And just to add to that, if I could, Alan, the National Biodiesel Board has voted in a unanimous policy that they would encourage, local fuel regulators, Conference on Weights and Measures folks, Department of Ag to go out and actually test the gasoline and diesel fuel pumps to actively enforce the biodiesel specifications to make sure people are delivering, ASTM quality fuel out there, and where they're not, to shut those folks down. So our industry is very concerned to make sure you meet the ASTM specs, as Rich said in his slides. We know that if you have an out-of-spec fuel, you can cause problems. So you absolutely, positively need to meet the spec. And one part that folks may not be aware of is that for the B100, in order to get the $1 per gallon tax incentive that's available for the B100, we put into place specific regulations that you have to meet 6751 in order to gain the tax incentive. And if you don't, the IRS has the authority to levy a fine of $32,000 per day for a minimum of 30 days if you're providing fuel that does not meet the ASTM specs out there. So we're encouraging, folks to enforce the specs and to do that, to the extent that we can. Right now, we have about 44 states, I believe, that have officially adopted 6751 as part of their state law for the biodiesel specs, and we're looking to get that number to 50. And we're encouraging every state to actively enforce the spec. Not only go out and test when there are problems, but actually test fuels periodically to make sure that everyone is meeting the spec out there. Because there are a lot of wildcatters out there who are producing a biologically derived something or other that really isn't. Biodiesel doesn't even come close to meeting 6751, but have kind of used the brand equity that biodiesel's developed out there. And we're very concerned about that group, which we call kind of imposter biodiesel folks, getting into engines, which we know will cause, the types of problems that, Bosch and Mercedes and others have seen in some of the materials out there. So fuel enforcement is absolutely critical.
And Steve, I'm sorry, could you just highlight again the states that have the kind of enforcement in place that you're hoping for there? You mentioned, what was the number of percentage?
We have 44 states right now have adopted 6751, and we're looking to get to 50.
Okay. Got it. Thank you.
Alan, if I might
yes.
add something here. While a lot of the customers fuel at stations, off-highway mining and heavy-duty off-highway applications, they typically have central tanks, and they purchase their fuels from jobbers or distributors. And they do. We certainly require, like for us as an engine manufacturer, that they are a BQ 9000 producer, so that they can reduce the risk of using bad biodiesel. So I would say for this sector of applications, definitely refer to your OEM guidelines, because you will have there what's required and what's recommended and so on.
Okay. All right, well, we are beyond our posted time for conducting this webinar, and most of the participants have stuck with us throughout this lengthy Q&A session, but and there are more questions that have been submitted than we can get to today. But I want to just sum up kind of where we are here. I think this webinar was a very insightful survey of both the policies and practice of the use of biofuel today, and it gives us some aspirations for the future of the kind of challenges that we have to overcome collectively. And I think I heard a very strong statement about standards and the importance of standards, and there's a lot of letters and numbers gobbledygook with ASTM, D6751, et cetera, but at the end of the day, those are the things that we hang our hats on for performance. And what I think we're interested in is the fact that we have high expectations for the diesel experience, and substantial amounts of progress have been made in
developing new clean diesel cars and advanced heavy-duty on- and off-road engine technologies that are among the cleanest in the world. And with that, it's incumbent that we have very clean and quality and consistent fuels that can be used in these very powerful and high-tech machines. So it's essential that we have that so that the biofuels are accepted by both policymakers and the user community, and that we have customers that buy these products and vehicles and equipment that have positive experiences themselves, that ultimately will bode for success for the entire industry at large, the producers, suppliers, the farmers, all the way up to the car manufacturers. So I think today has been a wonderful set of presentations, and these will be made available on the Diesel Forum website. That's dieselforum.org, and you can listen to a recorded part of this. You can download the presentations and look at those. This is a survey, first webinar that we're doing in this area, and we expect, based on today's interest, that we'll be holding some additional sessions coming in 2010 that will maybe probe a little more of these topics a little more deeply. And from the looks of the questions, there's plenty of interest out there. But I do want to thank our presenters today, who have been extraordinary with their time during this very busy time of the year, and their comments and responsiveness to questions. And that's Bob McCormick from NREL, and Hind Ali Akbar from Caterpillar, Walter Putz from Daimler, Rich George from BP, and thank you also, Steve Howells, the Technical Director of NBB, for joining us here today. That you added some very important insights for us. So on behalf of the Diesel Technology Forum, I want to thank all of you participants for staying on with us today. Again, the presentations will be available at www.dieselforum.org. And if you're interested in more of these kinds of webinars on this and other topics, please stay tuned. We'll have a schedule to be announced for 2010 very shortly, and look forward to providing you with more information on clean diesel technology. With that, Kristen, are there any other housekeeping details I need to cover?
No, everyone that registered will receive an email with all of this information.
Okay, then. Well, thank you, everyone, presenters, participants. Have a wonderful day and a wonderful holiday season. Thank you for your attention.